In this Architecture Today webinar with program partners Shuko, Modern Methods of Construction, Future Models. Presentations from Adam Jones, Modern Methods of Construction Strategic Change Manager, Department for Education. Judith Barker, Director of Programs and Governance, South East Midlands Local Enterprise Partnership. Harbinder Birdy, Partner Infrastructure Sector Lead, Hawkins Brown. Simon Bayliss, Managing Partner, HTA. And Adrian Robinson, Senior Lecturer in Construction Technology, Oxford Brookes University. In a moment, your chair, Ruth Slavid, but first, Schüco UK's Commercial Director, Sean Butler.
Welcome to the latest in our series of 80 Schüco webinars. In today's webinar, we will hear from 5 experts who will consider how best to unlock the potential of modern methods of construction, MMC, to bring about a step change in the delivery of large-scale projects. As part of the discussion, we will focus on the capability of MMC to accelerate the move towards net zero construction and what we have to do to ensure professionals have the skills and knowledge to release this potential. As a company, we are often asked how important MMC is to us, and the truth is that the benefits that MMC brings are critical to our manufacturing strategy and are a fundamental aspect of any product we produce. We've dedicated significant resources to developing systems that utilize off-site fabrication, as well as the digital infrastructure that supports this. We believe that we are at the start of a new age of building better, quicker, safer, cheaper, and more sustainably. And I'm really looking forward to hearing the presentations and discussion today. Thank you once again for joining us. I'll now pass you to Ruth, who is chairing today's event.
I'm really pleased to be here. This is a subject that we seem to have been talking about for a very long time. I did a quick Google and I certainly found a report from the National Audit Office in 2005 that talked about modern methods of construction. I'm sure there are earlier references as well. But for a long time, we seem to be talking. And I think what's really interesting in what we're going to hear from today's presenters is that we seem to be we're doing now, and we're making big plans for the future. So I think this is going to be really enjoyable, and I think it's going to make you all think about lots of things you'd like to know, which is great, because I would like to remind you that we have a discussion session at the end when we have the opportunity to pose your questions. So please do send the questions in as they occur to you while people are speaking, because I know we can all forget if we think we'll send them in later. So look forward to seeing your questions, but more than anything, to hearing from our speakers. And I'm delighted now to introduce the first speaker, who is Judith Barker, who is Director of Programs and Governance at the South East Midlands Local Enterprise Partnership. Judith.
I'm really pleased to be invited to the Architecture Today presentations about modern methods of construction, and I'm going to focus on the Modern Methods of Construction Centre at Bedford College and how and why Semlep funded that facility. Before I do that, just a quick overview of Semlep. Semlep is the South East Midlands Local Enterprise Partnership. We're a private-public partnership supporting sustainable economic growth across Northamptonshire, Bedfordshire and Milton Keynes. And we're one of 38 LEPs in England. And you can see our mission is to focus on doubling gross value added by 2050. We cover 6 local authority areas as shown on the map above. And as you can imagine, we're very much a high growth area with growth in business numbers and house building. And the growth rates in this area are above average for the UK. We have the second highest population growth in the 20 years before 2019. And of the housing completions, we have 4.5% of new housing completions, while actually only having 3% of the population. So you can see for our area, sustainable methods and modern methods of construction are a really big issue and something that we want to advance. So what is Semlep doing about that? Well, we have 3 areas of activity. We firstly have an economic strategic direction that we set with our private and public partners. In 2019, we published the local industrial strategy, and then that was updated given the COVID situation with an economic recovery strategy. And that includes looking at particular sectors, what those sectors need in terms of skills and growing and future growth. And it also includes sustainability and inclusion and how we support those agendas. The second area in the teal on the diagram is around convening and facilitating. And that's really how we work with partners to deliver the economic strategic direction. And then the final area is how we use our funding to support that agenda. And that's what I'm going to focus on now. So over the last 7 years, we've had £265 million of capital funds from government called the Local Growth Fund to support sustainable economic growth. And many of those projects are now coming to a conclusion. And many of those have been focused on supporting skills projects with our higher education and further education colleges. As well, in 2020, we were able to bid for a significant amount of funding under the government's Build Back Better agenda during the summer of 2020, when the focus was on COVID recovery. That was then named the Getting Building Fund, and we secured 27.3 million from the government to support 11 projects. One of those projects was the Modern Methods of Construction Centre at Bedford College. We launched that fund in June 2020, and government approved our bids in August 2020, very quickly after the original submission. We had a huge pipeline of projects which we'd attracted in 2019. We'd already appraised and considered, and so we put the best of those with the best credentials for the Getting Building Fund into the submission, and that's, I think, why we were successful in securing so many funds. We're now continuing to work with our partners, local authority and higher education, to assist them to access new funds, but the Getting Building Fund and the Local Growth Fund is no longer available, as all of those funds have now been allocated. But I'm going to talk a little bit about why we supported this particular project and how it fitted. So in terms of assessing any particular project, we look at the 5-case model, and we look at these 5 questions. Does it achieve our strategic objectives? Does it fit with the national, local and regional policy objectives? So that goes in the strategic case. Does it provide good value for money? Is there a demand for it? Is there a need for the public sector to intervene? And what's the value for money? That's the economic case. And then we've got 3 delivery cases: the commercial, financial and management. The management covers, can it be successfully delivered? The financial is there a clear budget? Is it all covered? And is it affordable within that budget? Have you got the rest of the funds? If we provide some grant, is the rest of the budget there? And then finally, are there suppliers who can actually deliver it? So for instance, have you got contractors available to build the capital project? So with those 5 areas, we're covering off the how and the why of the project. And that's how we assess each individual project. So what I'm now going to do is just talk a little bit about how this particular project fitted with those 5 areas. So the first question we looked at was the strategic case. So the question we were asking ourselves is, does this proposition from Bedford College to build a Modern Methods of Construction Centre, does that fit within our economic strategy of the time, which was the economic recovery strategy? And we looked at these 5 areas: ideas, people, infrastructure, business environment and place. Clearly from ideas, it's very much talking about how we innovate within construction. In terms of people, it's allowing people to develop new skills, to innovate in the construction industry, do things differently and bring more people with more skills into construction. So absolutely, it was focused on people. It was going to give us a key building at an FE college, which had net zero credentials. So absolutely, it was contributing to the infrastructure and indeed the street scene. It was creating a business environment where construction businesses could come into that space and benefit and learn about new methods of construction. And as I've just implied, it's making a difference within Bedford to the people and the street scene. So it was impacting on place as well. So absolutely, the strategic fit was strong. In terms of the economic case, the question is, was it going to be an appropriate use of public funds? Was it going to deliver value for money? Was it the right thing to do with public money in this case? Well, clearly, in an FE college, it's unlikely that the private sector would have delivered this scheme by themselves. So we could see that it was an area that was ripe for public sector intervention. And we also know that innovation in construction has been very slow moving. So it's absolutely an area where the public sector could intervene to innovate and drive that innovation. So there was certainly a case. And then we looked at what would be the direct economic impacts of this investment? Well, there'd be lots of new learners or learners with improved outcomes that would continue to deliver economic growth for some time to come and in a more sustainable way. There'd be the traditional trades would be supported, but in new ways. But there would also be project managers who would be learning their skills for delivering projects in a sustainable and modern construction method, as well as actually generating new systems for building. So all of those things were going to have a direct impact. And then those things would have a wider impact. So they would have an impact on the house building in our area, the construction of other buildings, schools, factories, warehouses, and all of the other activity that's going in our area. And it would allow the construction industry to innovate, become more profitable, and prepare for net zero carbon. So all of those things suggested that there was a strong economic case. And overall, when calculated, the benefit cost ratio was shown to be over 4. And what that means is for each pound of investment, we could anticipate £4 of benefit, which is very strong value for money. And this gives you some of the numbers and an image of students in the space. So you can see over 500 students would benefit in new educational facilities with a significant impact of that learner outcome in a net zero carbon building with an improvement of the street scene as well as those wider outcomes being delivered. So the third area after the strategic and economic cases was to look at deliverability, to look at those management, financial and commercial cases. The college supplied a detailed risk register and project plan. They were clear one of the risks was planning permission and that they had a clear plan to secure that with delegated approval and working with the local authority. The contractor had to be procured, but they had strong relationships with contractors who'd worked with them successfully before, and they were confident that that could be brought into place very quickly, and indeed it was. And one of the key areas on the deliverability is they had strong project management and a strong track record of delivering, even during COVID, on other projects that we had supported, as well as others within the college's estate. So the final bit of the jigsaw is the rest of the match funding. The original project cost was just over 4 million and they were seeking 2.9 from us to be spent over 2 years. In the end, the project cost was over 6 million, not because it overran, but because of the investment we made. They were able to attract other funding, including from the Connolly Foundation, to invest in some of the equipment. And that is why the building was later named the Connolly Centre. So in conclusion, we were really pleased to be able to support this project because we believe it will make a real difference to skills in the construction area and specifically in the Semlep region. And I'm very happy to take any questions.
Please do send in your questions, which we will ask at the end. And I just wanted to ask you quickly about the courses that are actually run at the college. Are people doing dedicated courses on MMC, or are these forming part of larger courses?
It's a real mixture between dedicated courses, but really embedding MMC into project management and the trades across the whole academic provision at the centre.
Thank you. And we will be talking to you later. But now I am delighted to introduce our second speaker, who is Adrian Robinson, Senior Lecturer in Construction Technology at Oxford Brookes University. Adrian.
Okay, so modern methods of construction and future models. So we're looking at the skills and knowledge for a step change in the construction industry. As a university, we've decided to talk about the things we ask students to think through when they're investigating and studying modern methods of construction. And a few key questions come to mind. What exactly do we mean by modern methods of construction, or MMC? And you would have heard of this term before, modular construction, But what exactly is it? And what is modular architecture? Is it the same thing? But perhaps the biggest question we need to ask ourselves is, haven't we been here before? This is Park Hill in Sheffield, arguably one of the better examples of precast concrete buildings. But we've been designing buildings like this for decades, and many of them have not endured, nor have they been well liked. The problems are not really technical. We know how to build industrialized architecture, but can it be socially acceptable? This refurbishment of the Sheffield Park Hill provides some hope in that respect, but it still needs to be positioned in a careful way in society. So what exactly do we mean by modern methods of construction? Modern, or new methods of construction, suggest links with industrialization. In other words, it is construction that's been shaped by the Industrial Revolution. The term modern is also associated with mid-20th century modern architecture, the modern movement, architecture that was shaped by industrial design, and it was through the introduction of greater mechanization and new materials and new techniques that a new architectural language was developed. This is the Futuro. It's a 1960s vision of what construction would be in the future. It's more lightweight, it has a new form, and it was developed by the Finnish architect Matti Saronen. The fiberglass flying saucer-shaped building was a product of post-war thinking in architecture. And looking on, 50 to 60 years later, we don't live in buildings like this, and it's interesting to speculate why, because the Futuro still looks quite visionary. There are many other examples of promising building types that have not been followed through. Buckminster Fuller's geodesic domes and the Dymaxion house from the factory in Wichita. Kisho Kurokawa's modular Nagakin capsule tower that was based on containerized modules. The house designed by Charles and Ray Eames. The design goal was to construct it entirely from off-the-shelf parts available from catalogues. We don't design buildings like that very often. Moshe Safdie's design for Habitat 67, a residential complex built around the time of the Montreal World Exhibition. It was a rambling complex of 180 or so interconnected precast concrete apartment buildings. Again, doesn't look much like buildings we design now. Arguably a more successful mass-produced system for the 1960s was the Consortium of Local Authorities Special Programme for Schools, or CLASP for short, which in its time was admired for its light, elegant and flexible buildings. These buildings remained successful for quite a while, although of course they had their issues, problems of heat loss, asbestos, cold bridging, and some acoustic issues. But even when we solve all these problems, we still don't build new schools and other public buildings in this way. It seems that we don't like our buildings to be too standardized. Okay, so what is modular architecture? And what is modular construction? And are they the same thing? Modular architecture is where there is a concept to design a building in a series of volumetric modules or panels. Ideally, the architectural ambition and the method are aligned, but this is not always the case. This is a 24-story high tower in Wolverhampton for student accommodation. It has 800 light steel modules, and the architecture is modular as well as its construction. This hotel in London was built using modular construction methods, but it doesn't look like a modular building. In fact, it's made of shipping containers. Travelodge hotels did not want the external appearance of the buildings to show that they were made of containers. It's modular construction, not modular architecture. Modular construction involves a method of production and assembly adopted by contractors and suppliers to make something more efficiently using industrialized methods, a way of building a permanent building, but using mostly factory methods. This is a highly engineered product, in this case using technology of intermodal steel shipping units. The units are manufactured overseas and fitted out where products and labor are lower cost. Then it is shipped using containerized intermodal transport systems. So to summarize about modular, we have found that this definition of modular to be useful. A module contains an independent system of complex components clustered together in a way that interactions between modules are simplified. It's these independent autonomous elements with simplified interfaces with ease for assembly and disassembly. So there is an implication of non-permanence in modular designs. Due to its autonomous modular nature, discrete simple connections, the building typology suggests modification and transformation. Snoozebox is a temporary hotel system. The idea is you pay to stay in a hotel near to an event, for example, by the track of Silverstone, where accommodation is suddenly needed. It's a completely autonomous system with a full set of off-grid power sources and other utilities, and the hotel is on temporary supports and can be lifted and transported to the next event relatively quickly. Okay, step change. So what are the new models? How can new methods bring about some step change in construction? How can we make construction safer, more efficient, and more sustainable? If we use more industrialized techniques, the build time on site will be shorter. It's going to be less disruptive, there will be less deliveries and less noise. Program times are more predictable. There is a quality control process that happens before products arrive on site. There is better control of pollution and waste in the factory. And when access is limited off-site, off-site manufacture works quite well. Use of factory methods are also known to be safer on site, more discreet, carefully planned installation events, requiring more skilled operatives, but it's safer because they're planned and anticipated. And yet the number of sites using more advanced methods of construction are very low. Less than 2% of sites use advanced methods of construction such as modular. So these arguments of time, cost, quality are not so straightforward as we think. So do industrialized techniques save time? Sometimes they do. It depends what follows. If the site is prepared while the modules are manufactured and the contract program can continue at an accelerated rate, then it will save time, but that's not always possible. Will it cost less? Probably not in capital cost terms. It might bring forward the opening of a building, leading to earlier income generation. But does the earlier income fully compensate for the increased cost of building off-site? Not always, unfortunately. What about factory-based quality? Factory-based, yes, but beware of the industry under pressure and also dealing with high capital costs and a temptation to reduce the quality of products. We have found that the reasons for using off-site and modular construction are not simply arguments of cost, time, and quality. There are usually other overriding practical factors. If there is significant standardization, say more than 500 units, allowing economies of mass production, then manufacturing makes sense. If there is limited access to site, minimal storage and space for loading and unloading, then yes, we would manufacture off-site. If there is a limited time frame, for example, you're building in a hospital location where construction activity is minimized, or you're building during school holidays, then off-site manufacture of modular construction might be justified. If skilled labor for on-site construction is unavailable in certain locations, then a modular manufactured building might be cost-effective. A very good example of constraints is the case of the floating homes in the Netherlands. We often use this example when we were teaching in construction. These homes are built with concrete bulkheads, which are cast in a continuous pour. The base, once completed, is floated through the factory to have the superstructure added, and in each case that is customized to suit the different client requirements. So how do we equip future generations? What models do we teach? Manufacturing using off-site methods needs careful definition. When we talk about levels of off-site, we need to be careful, because we talk about in terms of modular, panel, frame, and pod. But buildings are more complex, and descriptions for manufacturing are often slanted towards structure, cladding, and first fix M&E. This is about 50 to 60% of the building budget. What about the other 40% that's on site? Nearly every building has some component of on-site construction, and more often than not, site construction and off-site construction and on-site construction are employed side by side in hybrid solutions. It's helpful to think in terms of levels of pre-assembly. For example, raw and processed materials have no off-site activity. Components that can be mass-produced are manufactured items. Sub-assemblies, which are factory assembled, can be assembled on before arriving at site. Volumetric and non-volumetric pre-assemblies are also factory-based units. It's also good to think about the impact of digital tools on the future models, because increasing use of computational data for communication and control of machines, computer-aided design, CAD, combined with computer-aided manufacture, CAM, and computer numerically controlled machines, CNC, are becoming more and more predominant. Timber, for example, is a particularly popular area for CNC, particularly in its new isotropic form, which has become a more industrialized method, particularly since computer numerically controlled machines. Manufacturing models or production strategies are also helpful explanations of design intent before assembly and construction. There are 4 generic production strategies: concept to order, which is like bespoke production; design to order, as a pre-design of a product; make to order, as a detailed design that can be modified; and make to forecast, which is a fixed design product that is produced to stock. It is helpful to use other ways of explaining this, and a good way of explaining this is through tailoring. Concept to order is like the bespoke item. Design to order is the pre-pattern design. Make to order is the pattern design, and make to forecast is the off-the-rail clothing. If we understand these different production strategies, we can then apply them to the production processes. And by that I mean procurement for some buildings, but also considering commissioning of new product development. So we have procurement for concept to order strategies, tender for design to order strategies, and new product development for manufacture to order or manufacture to forecast. Buildings are made up of a large number of products, but can buildings in themselves be considered as products? This happens more easily with temporary buildings, where there is a blurred line with mobile architecture, such as static caravans and mobile homes, as we've already seen. For example, these tiny prototype houses in the Netherlands. I'll leave you with this final example. This is the Ecocapsule. It's a low-energy, off-grid building with its own power generation. It has an attractive shape which seems to have universal appeal, and it helps us to keep an open mind about what the future models will be like.
Thank you very much, Adrian. And I know you said we should end up with a future with an open mind. You've given us a lot to think about. Are you generally optimistic or not about the future of MMC?
Thank you, Ruth. Yes, I mean, we are optimistic, aren't we? Because we're trying to bring about improvements in the industry. I think possibly what's happened in the past has been an over optimism about sort of technical solutions to MMC. I think that's where we need to perhaps learn from that and learn that the solutions are more complex socially as well as technically developed.
I'm sure we can talk about that more later on. So I just remind everyone before we move on to our next speaker, do please send in your questions as they occur to you, which should make our final discussion as lively as possible. And now I'm delighted to introduce our third speaker, who is Adam Jones, who definitely has the right job title for this presentation. He is MMC Strategic Change Manager at the Department for Education. Adam.
Thank you. Today I'll be talking through the Department for Education's current and future models for MMC delivery. The Department for Education's vision is to provide a world-class education, training and care for everyone, whatever their background. And we'll do this by focusing on the following 4 outcomes: driving economic growth, boosting and levelling up education standards, support for the most disadvantaged and vulnerable, and providing the best start in life. The UK's public sector estate is enormous. Valued at over £500 billion, it provides the platform for delivering services to the citizens of the United Kingdom. Our schools estate forms a significant portion of this, with over 21,000 schools in 64,000 buildings and an internal floor area of 78.8 million square metres. Schools and universities together account for 36% of all public sector building carbon emissions, and the DfE spends over £900 million per year on energy. Nearly 10% of total public sector spending is on education, and of this, roughly 5% is allocated towards capital delivery infrastructure investments, mostly on improving the school's estate, either through renovating or replacing existing buildings or funding the construction of new schools. Last year, DfE Capital invested £4.8 billion in construction projects, 85% of which was directed towards the construction of schools. This makes DfE Capital one of the UK's largest construction clients and gives us, as a government department, a unique opportunity to leverage our construction investment to positive effect. The DfE's key challenges are condition of existing estate, sufficiency of school places, and carbon reduction. In the same way as the automotive industry evolved during the 20th century, the construction industry in the 21st century is now making that same transition from traditional construction, which is often highly bespoke one-off projects with a high degree of on-site construction and reliance on skilled trades, towards factory-based construction with a higher degree of standardization, off-site fabrication and batch processes, and through to manufactured or Dfma production with mass customization, continuous flow, and manufactured components. The DfE have also been moving along this path via a series of iterative steps. Our first generation projects in 2015 were a handful of projects reprocured to off-site providers to see what MMC could offer. This opened up the way for a second batch of projects to be delivered via alternative frameworks. And in 2017, the DfE launched its first off-site component primary frameworks. This was closely followed in 2018 by an off-site secondary block framework. And in 2020, we launched our £3 billion DfE off-site schools framework. And out of all of these projects has come a good deal of learning and experience. To date, the DfE have delivered 103 projects with an internal floor area of 260,000 square metres and a combined value of £750 million. We have a further 110 projects at various stages of delivery currently, with a combined value of £1.49 billion. In the DfE, we're fortunate to have a strong pipeline of suitable projects that have allowed us to advance the government's MMC agenda. Our schools projects tend to have standardised accommodation and area data sheets, repeatable spatial relationships and adjacencies, highly standardised specifications, digitally enabled workflows, strong pipelines of future workload, delivered through long-term frameworks, leading to contractor-led standardised design solutions and a culture of innovation and collaboration. One of the aims of an off-site MMC or Dfma approach is to move more of the value creation into highly controlled manufacturing environments, then to bring large-scale assemblies to the development site where they can be quickly assembled and completed by the on-site finishing teams. The sorts of building elements that are particularly suited to off-site production are depicted here: superstructure, services, internal finishes, substructure, and FF&E. When each of these building elements are taken together, pre-manufactured values of 70, 80, or even 90% can be achieved. Some of the potential advantages of bringing more of the value creation into a manufacturing environment include cleaner, safer, and more controlled working environments, improved workforce stability and welfare, reduced workforce transience, more inclusive and diverse working environments, added to which many of these facilities are located in areas of higher deprivation. It's recognised that the short-term impact of COVID-19 has been detrimental to the productivity of the construction industry in general. However, we have seen examples of how MMC construction has managed to overcome these challenges. One example of this was a 2FE primary school called Isambard Kingdom Brunel Primary School that was delivered by Portakabin on time and on budget despite the first COVID lockdown. When the UK first went into lockdown on Monday the 23rd of March, Portakabin had just completed the off-site fit-out and the modules were sitting in their manufacturing facility in York. The building was ready to dispatch with all the groundworks and foundations having already been completed on site. And to enable the site-based team to install and then complete the building as planned, the contractor's health and safety team designed custom operating procedures in accordance with the government's COVID-safe working guidelines. By limiting the number of operatives on site, the on-site team were able to progress the external works. Trades were allocated to defined working areas to ensure social distancing guidelines were met, allowing everyone to continue to operate in safe working environments. Made up of 44 modules and split over 2 stories, the permanent school building was installed in just 9 days. Following the first lockdown, the DfE undertook a retrospective analysis of our MMC projects in comparison with a sample of conventionally delivered projects. And we were interested to discover that our MMC supply chain were able to resume full production after only 5 weeks. The DfE have an important role to play in the government's net zero carbon commitments. We have established a dedicated sustainability and climate change unit to develop whole systems approaches that include climate education, developing green skills and careers, developing supply chains, and improving the education estate. In my view, one of the most exciting and interesting pieces of R&D that DfE Capital have undertaken in recent years is called Gen Zero. We worked in close collaboration with other government agencies and externally appointed consultants to develop a standardized Dfma zero carbon school prototype. The end output was an ultra-low embodied carbon standardized platform kit of parts that could be configured in numerous ways to create virtually any school setting. One of the first stages of the design process was to rationalize the spatial arrangements to suit different construction methodologies. Teaching accommodation is mostly short-span cellular spaces, while halls tend to be long-span structures, which are suited to different construction techniques. And in between, we have the commons, which are a hybrid of short and long-span spaces. Key to our thinking was the use of standardized grids and flexible accommodation. Here you can see the standardized grid of 3.6 meters, which is subdivisible to 1.8 meters, with a 7.8 meter deep teaching zone, a 2.4 deep circulation zone, and importantly, an additional 1.4 additional and ancillary zone for servicing, storage, and flexible spaces. The spaces within a typical school tend to follow standardized area requirements, which you can see listed on the left. And you can see how these sizes work very conveniently into the standardized grid. And they're flexible to allow various other alternative arrangements of spaces. Having optimized our spatial rationale, the next step was to develop the building fabric. And here you can see a composite structural floor unit, which is also based on the 3.6 meter grid. And standardized repeatable structural wall systems with standardized openings that connect together to enclose space. The result was the creation of an optimized kit of parts that is ultra-low embodied carbon and can be configured to create any primary, secondary, or SEND building. Here you can see how all these components are brought together to form a whole school solution. And here is a visualization of the external appearance in which you see the widespread use of timber in the external facade, giving a soft and natural aesthetic. When considering the DfE's next steps, I believe an important reference document is the IPA's Transforming Infrastructure Performance Roadmap. TIP 2030, as it's known, is a long-term change programme with a 10-year horizon to tackle systemic problems with the performance of UK infrastructure. The programme explains how the government will ensure that projects are delivered quickly and efficiently, using the government's influence to drive MMC. The document includes focus areas, one of which is the increased use of platforms, or rather standardized kits of parts that can be brought together to create multiple building types. It outlines an approach based on harmonized pipelines of work, a platform rule set that defines the requirements for all components, and a catalogue of parts that can be configured in various ways. This allows investment to flow into distributed manufacturing centres that efficiently produce large-scale construction elements that are interoperable and can be brought to site for final assembly. An important aspect of this approach is the dataset that monitors the performance of those assets and feeds back into the platform rule set. For some, this may seem ambitious, but we feel DFE have already made a good start in delivering some of our new build school projects in this way. I hope this presentation has given you an overview of the DFE's current and future approaches to MMC and Dfma. Thank you.
Thank you so much, Adam. And that certainly is an ambitious programme. I just wanted to ask you quickly whether or not you feel this is applicable to existing schools, especially schools which need modification rather than complete new builds.
Yeah, indeed, the existing estate is certainly a significant challenge. About 60% of our education estate was built pre-1976, so there's certainly high condition need. But I would say that not all projects are suitable for MMC. And what we're very careful to do is to triage our pipeline early on to determine which projects are most suitable for MMC approaches and which are better suited to traditional construction. Where it's a new build replacement of existing stock, Adrian has already outlined some of the key advantages, but from an educational point of view, that's particularly pertinent in terms of reduced on-site disruption and better educational outcomes. I think since the majority of our projects are refurbishment, I think there are aspects of an MMC approach that are transferable to that workflow, such as BIM, digital, standardized layouts, increased R&D, whole life approaches to cost and carbon, and increased pre-manufactured value. We've been working with academic partners to model the carbon emissions from existing estate, and one of the targeted MMC approaches that we're applying or will be applying to existing buildings is via the decarbonising heat programme in the form of off-site manufactured volumetric plant rooms and energy centres that can be plug and played and delivered to any existing school.
Thank you very much. There's obviously going to be a lot to talk about later. We are getting some really interesting questions coming in, but do keep those questions coming, and that will enable our debate to be as lively as possible. That will be at the end. But right now, I am delighted to introduce our next speaker, who is Harbinder Birdy, and he is Infrastructure Sector Lead Partner at Hawkins Brown. Harbinder.
I'm going to be talking today about Tottenham Court Road Station and Liverpool Street Station, which are two stations that we've delivered. This is Hawkins Brown. We're a practice of 300 with studios in the UK and North America. And we've been working on Crossrail now for over 20 years, actually. And to put it in context, this is Tottenham Court Road Station. This is the two ends of the station, which straddle Soho Square, located underneath Centre Point, and Dean Street, which is on Oxford Street. And this is what we're building underneath. And this is for the past 12, 13 years. Tottenham Court Road has been sort of constructed whilst the sort of the station above at Tottenham Court Road has been sort of operational. So it's a huge task, engineering feat that's been sort of undertaken over the past 12 years. And these are images of the two completed stations we should be able to use later on this year, Tottenham Court Road on the left and Liverpool Street on the right. Liverpool Street was actually designed, the concept design was delivered by, designed by Wilkinson Air Architects, and Hawkins Brown were the architects actually delivered the station for the past sort of 7 years. But I want to talk about prefabrication. This is an interesting fact where car production is 86% efficient. When we look at construction, it's 30%. And so Dfma offsite manufacturing is looking to change that. And the reason being is, as we've probably all seen, in terms of Brexit and the skill shortage, is the demand for construction is increasing. And yet the labour that historically would construct those structures is reducing. And so offsite manufacturing is key. I wanted to take one component of Tottenham Court Road Station that we actually used offsite manufacturing. You've probably seen, particularly in London, there's an enormous amount of homes that are being constructed, typically clad in brick. And one of the things that we really wanted to do here was use Dfma and offsite manufacturing to construct the envelopes of the buildings. And we had two character buildings. So this is the only structure along Tottenham Court Road, along Crossrail, where Crossrail commissioned the same architect to design the station as well as the oversight development. And it's arguably one of the most sort of complex integrated TOD developments along the Crossrail line. But there's two different characters to the two buildings. The front building is a station building with a residential above, and it's modern and contemporary. But the rear building, Block D as it's known, has operational facilities in it. Again, residential above, but what we wanted to do was the planners wanted us to, in a way, mimic or do a contemporary take of some of the Georgian townhouses that were historically there in Soho. And right from the outset, I think it's key when you're designing this is a client buys into offsite manufacturing when you're actually sort of doing the development design, and Crossrail were fantastic in championing that throughout many of their sort of station projects. What we did was that we actually used Revit. So we're using a combination of Bentley for the rail assets and Revit for the assets above. And what was fantastic about using Revit was that what you could do is that you could essentially sort of codify each of the elements, which will then get tracked back into a schedule. And then for the contractors, what they were able to do is both sort of price, the quantity, etc., and also sort of deliverable. So the software now is geared up to aid both health and safety in terms of construction, but also aiding quants and material, which ultimately reduces wastage. One of the key things was actually how do you get on a busy Christmas day materials onto site, especially on Oxford Street. So one of the reasons why we did use offsite manufacturing is that you just needed less people on site. And actually what we had to do was make sure that we were designing components that were able to be delivered onto those constrained sites. And the site above is Dean Street, Tottenham Court Road, and the site below is Finsbury Circus in Liverpool Street. This is a mock-up of the facade, which has actually been taken from within the factory that that constructed the facade. And this is Langerock. Langerock were the tier 1 contractors. They have a big offsite manufacturing plant in the East Midlands. What was great about having a mock-up in a controlled area was that you could sort of snag it well. And what you could do is that you could take elements of the design and basically benchmark the quality that you wanted, and all parties are there. And so it's a great, safe way of actually sort of ensuring good quality. And then the panels actually came literally driven down the M6, then literally loaded on site. And you can see it's just a brick facade, insulation behind, concrete frame, that's the vent shaft on the right, and then just install. So not one bricklayer, there's no scaffolding required. And this is the time, it's 4 weeks. We say 4 weeks just in terms of program. But what you had to do was ensure that you were developing the design in the design stages with the supply chain and the contractors. And so the investment comes at the beginning of the project rather than actually on site. And this is the quality of the brickwork, which is fantastic. It's like a glazed brick, which was laid offsite, constructed in the East Midlands. And this is a current site shot of the station oversight development, which is under construction. At Liverpool Street Station, I mean, this is one of the station ticket halls in Broadgate, which is in the City of London. You can sort of see the majority of the actual sort of operations of the building is actually sort of all subterranean. And one of the design drivers there was actually to have a soffit which was uninterrupted by any comms or lighting. What we did with what we designed with Langerock and Wilkinson Air was a series of precast sort of soffits that were effectively a series of components. And what they would do is that they would have reinforcement integral into the precast soffits, and then they were lowered on. So effectively the soffit is a ceiling, it's a piece of sculpture, it's a piece of structure. And above that, what you'd have is a street, public realm, an oversight development. And here, what you can see the image on the left is one of the excavations into the ticket hall in Broadgate ticket hall. And tunnels. So just in terms of scale, when you do visit Crossrail, a London Underground platform is 100 meters long. Crossrail is 240 meters long. So it's the biggest underground metro in the whole of Europe. It's only the only other station of this same scale is based in Hong Kong. And this Langeroog, we actually delivered 2 of the stations with Langeroog, and that was Tottenham Court Road Station and Liverpool Street Station. And this is their factory in the East Midlands, where they which is called Explore. And what they do is that they develop precast building components. And what they offered Crossrail was to actually create the platforms using precast. The original design was in situ, and on Tottenham Court Road, which is sort of, we have a curved platform, we created that using in situ concrete. Whereas at Liverpool Street, where the platforms were straight, there was an opportunity to use precast components. And so essentially they looked at how fast it would be to actually construct the two, one using traditional methods in situ and the other one precast. And so you can sort of see the images on the left and the right, just in terms of personnel on site. So again, you have the platform tunnels, which have various sort of kit in there, which enables the self-loading of the precast components. But you can see the difference here in terms of time. I mean, you can lay the platforms almost like 3 times as fast within using a precast method. But if you look at that figure there, 57-7 in terms of operational people in a confined space. And so there's huge savings in terms of manpower down there. Incidents, these were just back strains. But again, there was no incidents whatsoever in terms of the precast components. And obviously with the defects, you've tested it all out in the factory. And what you're doing is that you're then just repeating using the same sort of mold with the same sort of QA in terms of sort of like snags, etc. So before it even leaves a factory, it's sort of snag free. And cladding the biggest tunnels. I mean, this is when you use the Crossrail lines, all the tunnel stations have the same environment, and that was a concept that was designed by Grimshaw, and the station architects would inherit that design intent. And what they would do is that they would then do the detailed design and deliver them. And so what we had to do is clad the tunnels, and these were using GFRC, glass fiber reinforced cement cladding. And we model all these using Bentley MicroStation. And that was sort of pivotal because actually the sort of like the software enabled us to actually then talk to both the engineers and multidisciplinary teams, but also to the fabricators. And this is a specialist engineer that we work with, Bryden Wood, who actually worked closely with Langeroog on the development of the cladding. And so we inherited essentially a design intent, but actually I suppose what's key here is actually working with the specialists in the industry that enable us to sort of innovate to reduce the materials. And so what we did was that we actually reduced the materials here from what was circa 25 mil thick cladding to 12.5. So you can imagine the sheer volume of material that we're saving, because Crossrail enabled the R&D and invested in the R&D early doors with the supply chain and the contractors to be able to make the product a lot more efficient. And so again, tests, mock-ups, this was the engineers really sort of pushing the performance specification of the material to make sure that it's fully compliant. But actually, how can you get the same visual finish, but with the least amount of materials? And this was actually, again, made by, fabricated and assembled by Langeroog. And actually, the GRC was actually hand sprayed. So these are sort of craftspeople that actually know by eye what 12.5 mil is. And so it's an amazing watching. They have these huge plywood molds, and then what they do is that literally visually. So this is almost like can imagine like a die and tray, but this is how a lot of the GRC that you see is actually sort of made in the UK. And interestingly, we did work, we're delivering Bond Street Station with another GRC fabricator, and they don't use this method. It's a completely different method. But essentially what they did was that literally by eye, they sprayed each of those individual panels that were made using molds that we could reuse. And these were the mock-ups. So again, mock-up was key. This is something that was invested in by Crossrail, so that all of the station architects and all the client body could actually see the sort of the visual finishes that were achieved. And that meant that when you went over to different contractors that were manufacturing the GRC, they actually had a standard benchmark that they could measure their material finishes against. And this is at Tottenham Court Road Station, where a lot of the cladding was being assembled, and you can sort of see the working environment that we are working in. So again, Dfma, small modular panels that can be sort of like lifted into place. And then also, should one get damaged, you take one out, and then whilst the station is not operational, you can actually replace them. And so all of those considerations were taken into place whilst we were designing from concept all the way to installation. And finally, this is the last slide. You can sort of see the visual finishes. I mean, this was made by the same fabricator and contractor, Laing O'Rourke. But what you have is a consistency. And this is particular to Crossrail, where when you do disembark from the train, the platform tunnels will have a very different look and feel and visual identity to the rest of the London Underground network. Thank you very much.
I think that's a lovely insight into the project. And I know I use Tottenham Court Road Underground Station a lot. I keep looking at that barrier and thinking, oh, when can I actually go through it? But it really is a once in a lifetime project. And I'm just wondering how much of the lessons learned there you think you will be able or allowed to take through to other projects that you're doing?
I think our future clients will insist that we actually take the lessons learned. I mean, what I've noticed is that when you're designing projects, there's no one manual that you take onto the next project for people to read. The sort of R&D and innovation is essentially in people's heads. So it's assembling those people that actually have that experience in terms of what's like construction into a team to inform the next project. And the big challenge is really is saving. It's very much saving the cost of how we deliver big infrastructure projects, particularly in the UK. So I think there's lots of lessons learned. I think Crossrail has been an amazing opportunity to take innovation into building projects like HS2 and the future infrastructure of the country, and internationally as well.
Well, we've had questions coming in about exactly how you measure some of those savings. We will ask those along with the other questions that people have sent or are sending when we get to the end, which will be after our final speaker, who is Simon Bayliss, who is Managing Partner at HTA. Simon, over to you.
Well, hello, everybody. I'm here today to talk about 10 Degrees in Croydon, the building right at the centre of your screen. I'm Managing Partner of HTA. We're a practice of a 50-year history. We have around about 250 staff. Our focus is in all things housing, and we do a wide range of things from architecture to landscape to planning, everything really that pertains to design around places that we all would wish to choose to live. We have a long track record of investigating better ways to build, really at all forms of development. Long, I suppose, tired with the design and build nightmare, where a carefully considered and designed scheme was then gradually eroded through the site stages. We always felt there was a better way to build, and the origins of that go back to a competition-winning scheme at Greenwich Millennium Village and various suburban schemes. But in earnest, we started a decade ago with this sequence of projects here, all now built, around about 10 projects over a period of about 10 to 12 years, delivered all with a single client, all built using factory-made technology. I'm going to talk mostly about 10 Degrees on the right-hand side, but it's really important to understand that this has been quite a long journey and quite a key collaboration to be able to achieve what we've achieved in this project. Here's the centre of Croydon as it could be. A number of projects, many consented, not all built, but gradually more of them are coming online. And you can see to the left there, just pointed out by my cursor, the tower outlined in green is now known as 10 Degrees, was variously 100A George Street or 101 George Street. And we started the project in 2017. It had the benefit of an existing consent for a 31-storey tower, but it had been vacant for 20 years, nothing much happening on the site, didn't seem to be moving forward. Our client bought it. We had worked with them on a number of projects, and they engaged us to develop a design for the site. The scheme we came forward with resulted in 546 homes. It's incredibly high density on a very small site, and was designed specifically to be delivered using modular construction, which was part of their system of our client. Some early renders of the base of the town, what it would give back to the public realm, sort of critical to engagement with the council and the benefit that they wanted to see with a wider master plan to the refurbished Fairfield halls connecting to East Croydon Station. You can see there the importance of the cladding and how that reflected in the folds of the ground floor, that public space to the left-hand side of the image, and an art gallery to be relocated elsewhere from the borough into that space there. But also the importance of the top of a building, particularly tall buildings that seen from a distance, understanding how they would be read from a distance and how they'd reflect the full height of the building. Now, as I mentioned, this is a modular scheme, so of course you would expect everything to be fairly orthogonal, and the building does stack incredibly well, but you can see there from the rectangles over the plan on the right-hand side, there's quite a high degree of variation. Modular construction has typically been excellent for student accommodation, for hotels, for any project that really has a lot of repetition, but also a need to be delivered quickly. And we saw the convergence of modular construction and the sort of burgeoning build-to-rent sector coming into the UK as really good bedfellows. It's very difficult to rent any housing, get any income at all until you've completed the building. So once you start construction, there's a real benefit to completing very, very quickly indeed, a real financial benefit. So that sort of outweighs any investment costs required for the technology itself. But also it tends typically there will be a great degree of repetition and a possibility of making early decisions around internal finishing, tiling, bathrooms, kitchen fit outs, that sort of thing can all be made very early on by a single client. There's very little choice given to or variation given to different apartments. At least that can be built in from an early stage. So George Street was delivered from a typical around about 1,500 modules for that 546 homes, and we conceived of it as sort of 4 key elements. This was a series of models that were exhibited at the Royal Academy at the summer exhibition. That concrete element on the left-hand side, you can see with the cores going up. The modules then follow the terracotta cladding, and then an exoskeleton of a sort of aluminium framing, which actually had no structural role, but created that sort of layering of the facade. Of course, very quickly we went through the approval process. It took us just less than 12 months to go from inception to approval, and along the way we had a draft committee with Croydon Council Planning Committee who asked us for the building to be increased in height, add additional homes, not happened before. But quickly we're into the ground as a large double basement. And then it really is what I'm going to sort of impress upon you is the speed with which developments can come forward using modular construction. So the time in the ground is obviously, takes the same as any scheme. The concrete cores come forward, and then you can see here we had for quite a while, we had 2 of these slip form concrete cores really sort of impressing on the skyline. And that work took a year to get through planning, starting on site in the beginning of 2018. It took roughly a year to get through the work in the ground and in those slip form cores. And then you can see the speed with which the modules arrived. So having designed all the concrete works and the groundworks, concurrently we're also specifying bathrooms and kitchens, sorting out the modules which are cut, steel cut in China, shipped over to Felixstowe, taken to Vision Modular Systems factory in Bedford, assembled into the fully fitted out modules. You can see the one there on the left hand side being craned off the back of a Vision lorry onto the site there. And really this is where sort of the exceptional speed takes over. Those modules are sort of 90% fitted out internally. Certain things are finished on site when the modules are bolted together and welded together on site. Obviously laying down floors and finished coats, paint and things like that are generally typically done. But other than that, they're very highly finished inside. And really it's the speed with which that happens. This is a sort of 9-month time lapse in the first 4 slide. So from that first module arriving in that previous slide, we 38 and 44 stories were positioned into site. And then you can see on the fourth slide, well, really by the third slide, those mast climbers have been installed, and the facade material is beginning to be installed whilst the modules are still being craned in above. So there's multiple layerings of activities going on site, very much an assembly rather than sort of the traditional model of a fairly noisy and dirty building site. It's a much cleaner and a highly engineered affair. Through to then on the right-hand side, you can see sort of the completion with that facade taken already all the way to the top. That has quite a lot of implications on how we design the building. So because the cladding is installed from mast climbers rather than perhaps a unitized system using the crane, they have to be handled by two operatives on a mast climber, so there are weight implications that need to be factored in. But all of that is work that we've understanding that we've developed over the course of that decade, working in collaboration with the same organization. So you can see there that left-hand image with the layering of the building, the core is there, the modules coming in, and then that facade coming up from the bottom, the middle slides slightly further on and nearing the top on the right-hand side. It's really sort of dramatic to see how quickly that emerges. And then as the building is kind of completed, you can see there, very similar to the CGI, the cladding, which is a terracotta system which we've worked with before. It's a whole range of colors and textures, but this is the first time it's been used, to our knowledge, in this formation, where we've actually assembled a series of pre-made panels in a sort of temporary factory in the basement of the building. The manufacturer worked with us to get the glazing right, to sort of reflect the colors that we were keen, and to create this sort of folded facade that has reminiscent of the mid-century image of Croydon and some of the nearby buildings, particularly the number 1 Croydon, the 50 pence piece. And the sort of detail of that, again, a critical part of a building of this scale with quite a lot of repetition in that facade. It's really important that the play of light and color and texture in that facade is really sort of thoroughly worked through in every aspect of the building, inside and out, and that's sort of really sort of driven the drive for that and subsequent projects. A sort of attempt at a real artistry between those materials, and it really is sort of sometimes quite dark and brooding on a dark and dull day. It can actually sort of kind of a blackness to it, and then on other days, particularly in sort of sunsets and sunrises, it can reflect the upper face of that folded panel and be bright yellow and really quite stark indeed. The left-hand image shows an installed module and a flat, and you can see the mast climbers outside. This was on the 2nd floor, and it was like this on day 1. But obviously the sort of level of fit out being done in a factory is to the highest possible standard, and to the lowest possible waste. We consider there's probably a 97% reduction in waste using modular construction of this form. The interior design also sort of trying to kind of bring through some of those concepts of the exterior as well. This is the entrance lobby, and being built to rent, it's a sort of place where people sort of sleep in their flat, albeit they're all to London Housing Design Guide's standard, to London Plan standard, but there's a lot of amenity to go with that as well. So if you went there today, the space at the bottom right is full of people working, and up at the top there's sort of lounges and professional kitchens that people can hire, and gyms, and outdoor landscape spaces and terraces both at the top and the lower part of the building, as well as that public space at the bottom. So a building that was delivered in it's a really just a little over 3 years from inception to completion, with those almost 550 homes, and every aspect of the building considered, through to the artwork and his Adam Nathaniel Furman sitting on the piece that he created, and really beginning to form a part of the centre of Croydon and its sort of rejuvenation, such that we're now on site with a building next door to the north on the right hand side here. This is College Road, a co-living building, really pushing now the possibilities of modular construction. Sort of note sometimes of the idea that modular construction, any shape as long as it's rectangular, is definitely a thing of the past. And I think that is reflected in many of the buildings. Here's a map of all the module shapes and sizes that we've been delivering through the buildings that we've been working on, which are sort of summarized in that snapshot there. And finally, just to say, we published a book in the middle of lockdown, probably not the best timing, but does capture some of those the experience has been gained through that, which we would obviously suggest that more of the housing that we build should be built in this way. And thank you very much.
Really fascinating to see that and how quickly it went up. And you showed us those images at the end of a number of projects. You showed us some outlines of some at the beginning. And the question I'd like to ask you quickly is, what about lower rise housing? What about houses? Is modular relevant to those as well?
Very much so. I think the metrics are quite different. Some of the issues in terms of planning and variation that's required are quite different. But there are certainly many manufacturers out there making really good progress in sort of expanding our capability across the UK to deliver modular houses as well as modular apartments. But yeah, I think they come with quite different challenges and both need to be sort of tackled quite separately with a similar mindset, but I suppose a different set of constraints. But absolutely, yes.
I'm now going to ask all our other speakers to join us. Here we all are. And I've had a number of questions that have been sent in. It's still not too late to send questions. There have been a couple of questions around the idea of volumetric construction and sending units in. People are asking about the cost of shipping air, particularly if you're shipping it from China, against the use of panels. And I think I might throw that back to Simon first of all, and then see who else would like to join in.
Now, I think that comes to the question you just asked me around houses and apartments. I think it can be quite effective and efficient to move apartments around, most of which obviously can fit on the back of a lorry. As I say, that sort of the metrics of housing, of living rooms and bedrooms being minimum widths, actually work reasonably well for transportation. And actually we found on 10 degrees the number of vehicle movements to the site were hugely reduced, and that contributed to the carbon reduction figure of somewhere north of 40%, which we've calculated in an independent study. So I think it's actually, I think there's a sort of view that transporting empty space can be perhaps inefficient, but lots of other things can be transported within the module, and overall the number of lorry journeys is still reduced. I think with houses where the widths tend to be wider than can be carried on a single lorry, there's quite a constraint there with the type of housing that can be delivered. And certainly I think that has led more investigations into panelized construction. But there are challenges, technical challenges around that at the moment in terms of how we ensure building safety compliance. I think steel frame and timber frame panelized construction, which has been very standardized for a long period of time, is now much more difficult to sort of determine compliance with structural behaviours under fire. So I think, again, my optimism in the industry is I try to keep it as high as possible, but I think there's quite a lot to do to ensure that aspect of modular construction can continue to progress. I think the benefit of the modular construction is it can be tested and replicated. The panelized industry, I think, has a lot to do to catch up with that.
That's interesting because we have had people asking questions about fire and about building integrity in these systems. Adrian, I don't know, you're looking at the different ways we've done things in the past and how we might in the future. And I don't know if you have a view around panelized versus modular construction.
No, certainly. I mean, just picking up on what was mentioned there about the impact of transportation of larger volumes that might not necessarily be as efficiently arranged as they would be if they were panelized. So obviously with panelized construction, there's an increased amount of work on site. The ideal with volumetric construction is that you have completed as much as possible of the electrics, the internal finishes, the first fix and second fix of all the services. So you have to, which is a good thing because the finishing and fitting out of projects, obviously, if you're doing that on site, then you've got all the transportation of personnel going to site to do all that finishing and work itself. So I think some studies have been done where that has shown that there is a considerable saving by being able to do that off-site. So it's a balance, isn't it, of two different methods. But Panelized has a very, very important role as well. You know, we can't build everything volumetrically, and Panelized is good as well, and also more traditional techniques, as I outlined earlier. I think, you know, it's going hand in hand. Those different types of approaches are all good. It's finding the right balance, really.
And I think another thing that people are worrying about, quite rightly, is to do with future modification. And also, I've had a question saying that the school standard modules appear to be an efficient solution, but what feedback do you get from occupants afterwards? So I'm going to go to Adam with this question. So one is just to talk about what sort of feedback you're getting, but secondly, to talk about modification, because we all know that all durable buildings really do get knocked around quite a bit, and what we think we want today is not necessarily what we want in 10 years' time. And actually, you know, schools have not got a great history in terms of longevity, have they?
Very interesting points raised there. So in terms of feedback, feedback from end users, that includes school children and staff who operated within school environments, is generally very positive. They're often very surprised, actually, when they realise that the building is an MMC project, because to them it looks and feels exactly the same as a conventionally built structure. What we tend to do is we invite our end users to visit MMC projects as part of the early briefings, just to encourage them to embrace and understand really the process, including the design. In terms of the briefing process, the use of standardized solutions, I think, takes a lot of pressure off academic staff who are often making these decisions. They generally aren't specialists in construction, but they are specialists in education. So to present them a compliant and well-resolved solution is often greeted with relief. So yeah, I would say the feedback is generally positive. In terms of modification, again, that's a really important consideration in our work. These school buildings will last for many decades and suit many different learning styles over time. So it's really important that we consider in our standardized designs future pedagogies and how education will be delivered. And what we're moving towards more and more, particularly in the Gen Zero approach that you will have seen in the presentation, is a long life loose fit approach, so that the building, the spaces are intrinsically adaptable and able to be used in various different ways. That part of a sort of value-based decision making, moving from cost towards value-based decision making, which I think underpins that decision.
Yes, and I think in our schools, especially where we know that the demands on the curriculum seem to be changed every year, that is really important. Simon, presumably, have you actually sort of costed the savings on defects elimination? And also, can you tell us a bit about the commitment that you feel that clients need to make to give you time to design beforehand?
I mean, I think, as I perhaps said in the presentation, this was an interesting case study because the scheme was designed for a client who's very they are a developer, but their reason for development is intrinsically linked to their ownership of an MMC modular factory. So there's a kind of integrated vertical supply chain from the acquisition of the land through to the construction and the manufacturing of the modules that brings the whole process, if you like, together. And that is, I think, fundamental in the route to their success. As a result, every part of their supply chain has been, if you like, designed to minimize both waste and defects. They're completely incentivized to ensure there are minimum defects in the manufacturing and in the installation on site, so that when the project is eventually handed over to the end owner and operator, there are minimal issues. I mean, it uses incredibly highly engineered processes, but also being based in the factory, people are doing the majority of the work, perhaps 75-80% of the construction is being done in factory conditions. So people are stood on the factory floor, they've got tools to hand, they've got skips, everything is cut to precision to fit based on sort of computer programs, but there's also skips in order to properly sort waste, which is hugely reduced and minimised. So the whole process really is sort of fundamentally set up to minimise both waste and defects in the way that almost we could argue that the past 30 years of design and build construction in the housing sector in particular has almost sort of been designed to enable defects and waste and to prevent anybody perhaps being individually blamed for it. So from that respect, we consider it to be absolutely the future. In terms of sort of measuring it and putting costs on it, I think that's perhaps more difficult. We have done, as I say, some very detailed individual studies around how much waste we've reduced and how much reduction of defects have been incurred, but perhaps a bit more difficult to put a price on it. Certainly from the architect's perspective, I dare say the clients might be able to help if we were to bring them into the discussion.
We've got another question which comes in as a very specific question for Adrian, but I think we might open it out a bit more as well. The question is, Oxford Brookes was planning an MMC module for the postgraduate architecture course, but it was derailed by COVID. Are there plans to look at this again? Do you know of other schools of architecture who have considered similar modules? Now, I don't know how much Adrian knows, but I think I would like to take that through after perhaps a quick answer from Adrian to Judith, who I suspect has looked at what the educational needs are and how well they're fulfilled, and see if anyone else has an opinion as well. So, Adrian, this isn't your department, is it? So do you know what's happening to the MMC?
I do. So we are actually planning an MMC, MSc in MMC,
Right.
and it's going to be design and management. So it's design for manufacture and assembly, and it's also looking at things like procurement and other issues, technology, but also building information modeling and sort of advanced construction techniques. So it's going to be more of that flavour, but we are planning one. And that's just starting. That'll be for 2023, September 2023.
That's fantastic news. And Judith, I'm wondering, in all that very thorough research that you did, how much did you look around and see what was available elsewhere in terms of education, and also how much you felt was needed?
Well, in terms of the research that was undertaken, Bedford College were presenting the business case to us, and what they were able to show in the business case that there wasn't within the Semlep area another college providing MMC support. And indeed, we understand that Bedford College is one of only two in the UK that are actually as FE colleges delivering MMC specific courses, the other one being in Wolverhampton. And certainly we're working with colleagues in government at DLUC, so the Department of Local Government, Communities and Housing, to actually share some of the experience of this so that it can be considered in the future housing plans of the department. We were very focused on the what I'd describe as the level 2, 3, 4 levels of skills development, rather than the HE, which would be levels 5 up to 7. So our research was very specifically about what would enable young people in going into the profession to have the skills and be ready to work on sites where this is developing. But absolutely, I think it'd be very interesting to take that study more widely into HE and what are the needs at the higher levels.
Back to Adam now, because I've had a question about government departments working together. And the questioner says that the Department of Justice has a scalable Dfma strategy, which can also be applied to healthcare, education, etc., that's now being used in the commercial office sector by a private client. So I guess the first part of my question is, do you know about this? And the second part is, how much discussion is there going on between government departments to share learning?
So yes, there is a lot of collaboration between the government departments that build social infrastructure. The 2017 presumption in favour of MMC, where it represents best value, was offered up to those 5 departments. So DFE is one of them. MOJ is very, very active in the space of MMC and have been doing some very innovative work recently on the large-scale prisons program. I think the idea of a platform solution, a platform DFMA solution, is a bit of a holy grail, and it's one that we're working towards across departments. The platform solution is a standardized part or component that can be used to solve or provide input to numerous different public sector buildings. So we're seeing that, and we've got within our supply chain some very advanced PDFMA contractors who manufacture for MOJ and DFE and others as well. So I think that work is happening. I think it's really important that the cross-government collaboration continues because we're all focused on, similar but subtly different problems. And by sharing our experiences across government, I think we can all move together much more effectively.
Simon, how much are you ploughing your own furrow, or how much are you aware of other innovations that are coming out?
Well, we work fairly hard to keep exposed to all the different technologies. I mean, it's probably wrong to say it remains a cottage industry. That would be entirely the wrong label for something which is typically fairly highly engineered. But it's working across a wide range of manufacturers active in the housing sector in particular. There are a large number of barriers that are preventing it becoming more widespread, both in the housing sector, sort of the lower 2-3 story individual family houses, and the apartment sector. I think the apartment sector is in probably better shape. There are more manufacturers who have aligned their supply chain and sort of secured their business, but it's still a relatively small number of manufacturers that are really excelling and demonstrating the benefits of this over traditional, and there is still a great deal of pushback in the industry against this level of innovation. From what is an industry that typically struggles, or traditionally has struggled to innovate. So we are talking to many interested suppliers, trying to get off the ground and trying to help them as best they can with the experience that we've gathered over the past 20 years, and giving it all the energy we can to try and ensure it succeeds.
I think you're connected now, are you, Harbinder?
Hopefully. Can you hear me?
Yes, you are. Fantastic. So before we start drawing this to a close, I just thought it would be interesting to hear from you, both as a large architecture practice, what the sort of level of knowledge is that you feel architects are coming in with, and how much more they might need, and also any cross-fertilization you're getting from government initiatives, etc.
Just touching on your point regarding graduates, I think there's a really big opportunity for graduates, especially at level 6 and 7. Like we have apprentices in our practice, to actually be focusing on DFMA whilst they're studying, so they're earning and they're learning, and that's like the new sort of way of I suppose in a way accessing architecture without having a huge financial burden. But when I do talks in schools, most children play Minecraft, and I just say to them, we just use Minecraft, but it's a more advanced way. So essentially, you've got this ecosystem of young people that have been using it for years, and actually, I think there is a need to have an option where graduates can specialize if they wish in DFMA and offsite construction using digital technology, because there is going to be such a need going forward. So I think what we have the appetite. What we really need is for the universities to work closely with professional practice and the industry, so that we have this pipeline of graduates coming through into the industry that are highly skilled.
Well, if anyone from a university is watching, there's a challenge for you. I think that's a really great point to draw this to an end. I'd like to thank all our speakers. I'd like to thank Judith Barker, Director of Programmes and Governance at Semlep, Adrian Robinson from Oxford Brookes University, Adam Jones from the Department for Education, Harbinder Birdie from Hawkins Brown, and Simon Bayliss from HTA. And just before we go, I have got one quick reminder for you, and that is about the Shuko Excellence Awards, which are now open for entries. And I know that the winning projects in the past have been really admirable, exciting projects, and that it's really worth entering, and the recognition is great. You can see the web address there, architecture-day.co.uk/Shuko-excellence-awards-2022. And I think after that, it's just really down to me to thank you all for taking part on behalf of Architecture Today and of Shuko, and look forward to seeing you at the next event. Thank you.